Hello everybody, welcome to our tap room. Today's tap room will be about 2-node Vmware hyperconverged setup, and I will be speaking about the setup, showing you some stuff in the IO meter. And just before we get started, I would like you to tell me in the question box whether you can hear me well and see the picture well. Okay, seems like my headset is working great today, as well as my monitor, so we can go ahead. So this is the banner you've all seen on our website. This speaks more about what we are going to do today, but I'll as well tell you more about this further. Next slide. That's basically me. I'm Alias Boris. I'm working at StarWind Software. I'm a senior solution engineer. I really like my job because I like troubleshooting, showing and explaining things. Also, I did learn here a lot, and I am still learning some stuff, and I am very glad to have such opportunity. So, well, this is where we go closer to our topic. So the first thing I would like you to see is the detailed StarWind device creation and settings we have in our device creation wizard, as well as the explanation of them. Then it's not going to be like a step-by-step configuration of the StarWind with VMware, because I have a detailed, like extremely detailed tap room. I had it back in the days, so if you want to, you can overview it. And then there will be a couple IO meter tests I would like you to see. And the last and the very important part is going to be questions and answers. And I would ask you to, you know, ask me as many questions as you have, and I will be very glad to provide you with answers to them. So right now, you're gonna see our ESXi, vSphere client over here, and these are 2 nodes we have. This is the first one, this is the second one. If you are planning to go with hyperconverged, since you might all know already that StarWind is a Windows native solution. Therefore, if we are going for hyperconversion and choosing VMware or VSXi as a VMware as a hypervisor, two StarWind machines will be on these hosts as a virtual machines, and we have them both configured over here. So regarding the Vmware configuration, basically what we need is, to have a vSender configured. Then we do a cluster out of these both hosts. I'm sure each one of you can handle that. After we do have those 2 hosts clustered, we will definitely require some storage. After that, we'll have to configure first StarWind virtual machine, then the second one. You can get an OVF template for those on our website. After you got the VMs, the very important part comes is the network adapters. We need to have at least 2 in order to configure in order to configure Asia in StarWind. So when we have 2 network adapters, we go into networking, and then we have to create virtual switches so that our VMs are able to use the NICs we did configure. So the way we configure these NICs is, this virtual switches, it is very easy. You click to add network. The first thing you want to do is to create a virtual machine network. After you did create a virtual machine network on the same virtual switch, so you'll go into properties and then click add, and you will add a VM kernel well, you'll add a VM kernel. Also, so I'm not gonna go very deep in it because we have it all over our website. You can find it in any resource. We have the information regarding this config everywhere, so that is very easy. I'm gonna go and explain you not such obvious things, but something interesting rather. And the interesting part in this virtual switches is the MTU, which is jumbo frames, and we do recommend enabling them. So this MTU on iSCSI as well as synchronization should be set to 9000. Also, another cool setting we do recommend for the hosts, and the one that is not obvious, going into advanced settings, selecting a disk, and the default size of the, just a second, let me quickly find it. So over here, as you can see, we have it configured in defaults, and the default is 32K. And we over here, we recommend setting it to 512. We recommend doing that on each host. So you click on the host, go into advanced setting, go into disk, then you find the setting, disk max IO size. It should be equal to 512. So we have it done here. After we configured the networking for our two StarWind VMs, so they will now have the access to the physical NICs, and we will be able to establish iSCSI connection and synchronization connection. We then go to our virtual machine, which I have right here. You'll see it on your screens now. And after that, you right click, go into Network Sharing Center. You can go into adapters, settings. You can see it from almost everywhere. And these guys should be configured according to our best practices, all in separate from each other subnets. Just like this. So 10, 20, 30, and 40. Yep, here we have them. And they obviously have to be able to communicate with each other. With each other, I mean this host and a partner one, and by host, I mean this StarWind virtual machine or sandbox. It's either way. So after we did configure the networking, and we are like 100% sure they are pingable, going back to the jumbo frame setting we did on our ESXi box while we were configuring a virtual switch, we also have to enable jumbo frames on these networks. And we can do that by clicking this configure button, going into advanced, and over here there is a jumbo packet which is set to 9000 over here, and the standard value and the default one is 1500. We want to have them at 9000. And this is very, very important because having jumbo frames enabled in ESXi and not having them enabled in StarWind boxes or sandboxes may cause issues. This means you really want to have them enabled everywhere. So now we go to the StarWind Management Console and get ready for the device creation. And this is where I will explain you it in small details. So the first thing is to know is, well, we will see our console just like that, and no servers will be here. Well, when you install it, you can click Add Server. By default, there is a loopback IP address which will add your local host. Or if you're not using your local host, I mean, and you are using StarWind Management Console just for management, and you want to connect to some other hosts, you can type in the IP address here, or give it a DNS name, or go to advanced and search in a certain IP range, and then eventually you'll get your hosts added to our console. After you have a server, you can right click on it, or you can even work with this panel, but I prefer right-clicking. You can right-click and go into Add Device Advanced Settings. So Advanced Wizard allows you to specify some settings where the Add Device Wizard just creates a device with all default settings. So we'll go with the advanced one. We have a choice of creating hard disk drive, tape device, or optical disk drive. In this particular setup and scenario we're working at, we need a hard disk drive. So we click next. And then we have a choice between virtual disk, physical disk, or RAM disk. RAM disk is the obvious setting. We don't need that because building our production on a RAM will make it very fast, but as soon as the host is rebooted, we will lose all our data, which we don't want to happen. Then the physical disk is a disk bridge. You are basically exporting your physical drive to the StarWind, and the virtual disk is the virtual disk creates a drive, and the way it does it is simply creates an image file inside your storage. So we'll stick with this one because it's easier to manage, and then you can specify a certain size, where on disk bridge you just have to provide StarWind with a whole volume, which is not so useful often because many people want to segregate, their storage to have like a separate LUN per each VM. Also, as far as I know, Microsoft and VMware best practices say that each VM needs to have its own data store or cluster shared volume, depending on which hypervisor are you working on. So we'll stick with a virtual disk over here. After that, you specify the target name. You specify the drive you want that LUN to be stored on. So we'll go with an E, for example, and we'll call this one a test. Over here you can specify its size. 1 GB is quite then enough for me to show you how we are doing this. And then after this we click next. Over here we have a choice between thick provisioned, which is a common objective file system. This is like the most standard device you can ever get, and LSFS. LSFS is really designed for a RAID 5 or RAID 6 arrays that have very low write speed and very good read speed. And LSFS is designed to boost write speed and do basically nothing for the reads. And if you have RAID 5 or RAID 6 and you have plenty of slow drives, LSFS is definitely the path you want to go. And if you're using SSDs or you have, SAS 10K, 15K in RAID 10, then thick provisioned is something you would like a lot more than LSFS. Over here, there is also a good setting, well, a nice one regarding the block size of the device we are creating. So the 512 sector is something which VMware likes to work with, and we will always choose this one, and it is a default setting when we are configuring something on VMware, where this 4096 byte or sector size is native to Windows. And in case if we are building up our infrastructure on Windows and only Windows will use this LUN, then we'll definitely select this one. But since we are working on VMware today, we will go with this setting. Click Next, and over here we have the level 1 caching setting, which uses random access memory as a storage. We have two modes. One of them is write back, another one is write through. Write back is by default recommended by StarWind, and write through is not for the RAM cache. So more about the modes. Write back is a mode which does a performance boost for reads and writes simultaneously. Basically, if you need like any very detailed or more info, there is like a huge and very cool with algorithms and stuff. There is an article on Wiki where you can read about these two modes. And then write through basically does the performance boost for read operations only. And then the third setting is, yeah, no cache at all. I would recommend selecting write back caching always, and the recommended proportion of its size is we recommend setting 1 GB of level 1 caching per 1 TB storage. So if we'll have like 2 TB, we want to go with 2 GB, so on and so on. For 1 gig volume, we wouldn't really need any caching at all, but I'll just keep the setting as is. And over here, there is a second setting, which is also caching, but it is level 2 caching, and we are using SSDs for it. You can use it or not. This is like, if you have SSDs, you use it. And then if you do not have SSDs, you don't use it. Also, there is a good question which many people are asking, like, if I have full flash storage, is there any sense to use level 2 caching? Yes, there is sense to use level 2 caching only in case if your L2 solid state drives will be faster than your main storage SSDs. But in any other case, if you want to use L2 cache for on the same storage, then there will be like no sense. And then if you have no SSDs, just stick with the setting no flash cache. We go next. Over here, we can create a new target for that device so that it is, there's a way to connect it to somewhere. Then we can attach it to an existing one, which is called multi-LUN, which StarWind can do. And then we can keep this target unassigned. We'll not be able to attach it anywhere at all. But later on, we can create a target and attach it to something, or attach it to an existing target later. I usually stick with a new target, and I mean, that's what I like doing, but just so you know, there are a couple settings for this one. And then the target alias, you can configure them if you want to, just change name. You can allow or not allow multiple iSCSI connections, and then the target name can be configured as well. Now we go next, and this is the final stage of our Add Device Advanced wizard. So we are clicking Create, and here we have our new target, which is called Test, and this is our physical disk. We can see that it is stored on D, we can see its size, we can see its cache, we can see its serial ID, so on and so on. We can extend it, we can replicate it, we can deattach from a target, force remove, like do almost anything we want to do with it. We can also go over here. We will see, I did it on D, right? So on SSD. We can also go here. We can see that a folder was created with the name of the target. We can open it. We will see the image file, and then we'll see the swdsk file, which is a configuration file of that device. It is written on XML. If somebody knows XML, he can try editing it, but I would highly not recommend doing that. And this is where our advanced device configuration finishes. About the replication, if we want to convert this device to HA, what we have to do is to right click on it or go over here and press replication manager, and then we need to add replication. If you want to create, high available storage, we have to go with synchronous two-way replication. We also have asynchronous one, but it is designed mostly for the disaster recovery scenarios or in some rare cases as a backup solution, but we will not be able to build up a highly available infrastructure using asynchronous replication, so we will stick with the synchronous one. After we selected the replication type we want to use, we need an IP address or a host name we want to replicate to, and I will go ahead and specify that. After we specify that, we click next. Here we can select existing device if we have one, or create a new one if we don't, and in this case we don't. The location is specified by default, so it was D for this one, we'll choose D for this one as well. You can modify the target name as you could while creating, the initial device. So pretty straightforward here. We then click next, and over here there is important setting which says change network setting. We definitely have to click here and specify our synchronization and iSCSI channel. I mean synchronization and heartbeat. We usually use iSCSI for the heartbeat. This is why I'm saying iSCSI. I'm sorry. So each time, even if you almost 100% sure you know which channels should be specified or something, I do recommend opening this once again and double checking to be sure we are doing the correct thing. So 161010 is our first synchronization channel, and we see it here, so we do specify that. Then we go back and see what IP address is configured on the second one, which is 162010. We do specify this as well. After that, we want to quickly look through the iSCSI. Oh, these are actually iSCSI, I'm sorry. So these are going to be heartbeat. And going back here, we have two syncs, which is 30 and I guess 40. Well, still want to double check it. So 30 and 40 are going to be our synchronization channels. After we specified all this, we just click OK and then click Next. Over here, we can choose to synchronize or not synchronize those devices after they are created. Well, we obviously want to synchronize them. If you don't, you may choose that setting, but I don't think you will. And after this, we are clicking to create a replica, and you will notice that our image file was converted to HA image, which makes it a highly available device. So we have this HA image here, and then we have this HA image here as well. We want to wait until synchronization is finished, and it is finished for both sides. So this device is synchronized and highly available. After we did that, we want to go to our ESXi, which we have over here, and go into storage adapters. And we want to do on both hosts. So over here, on the first one, we'll go into properties and go into dynamic discovery. Type in the IP addresses of your iSCSI network in the virtual machine, in the sandbox. So basically we go over here, we go back to our networking and sharing center, we open iSCSI 1, we check this IP address, remember it or write it down. Then we do same thing for the second iSCSI, we go back over here and then type in those IP addresses here. After we did that and close, it will ask us to rescan. We do a rescan and then we'll see that our devices is appeared over here. We'll do a quick rescan to see that our new device has appeared. Yep, there it is. It's actually quite a few of them, but this is the one we need. It is 1 GB. And we will also have to do just the same thing over here on the second box. So type in everything we need in dynamic discovery and then do a rescan. We also see that devices appeared over here. After that is done, we are going to the storage on both hosts and then clicking, well, actually on the one host, on the second one we won't need. So we click add storage, disk 1, and then we'll select the one we just created. We'll click next, and we, give this data store a name, and we would be able to add it, but it is unfortunately 1 GB size, and VMware, needs 1.3. But finishing this wizard would lead you to have a highly available data store which is capable of storing your VMs, and your VMs will be highly available. So in case one node goes down, that VM would migrate to the second node and continue working. Everybody will be happy. So going back over here, and after I did explain the configuration of the device, detailed one, and quickly explained the way we can configure our VMware. If you did not understand, the configuration part, I want to say once again, I had another taproom video, and it is available on our website where I explained each step slowly and steady. We went through all the configuration, and you can find that video over there. And I want to have this tap room for the iMeter, for the device creation, and for the questions and answers, like more towards those topics rather than the configuration one. So have to stop talking and go to the iMeter. So over here I have two devices. I prepared them for the tap room. As you can see, this one is called test tap room. So this is the thick provisioned image file which has common objective file system on it, and I did it is a 10 gigabyte one which has caching on it, as well as this LSFS which is also 10 gigabyte one and has caching on it, the same amount. And then I'll compare those to our SATA volume, just SATA volume with no StarWind at all. And a utility that I'll use for that is iMeter. So we want to open iMeter. I have a test set ready for that, and it is initially for the SATA. So over here I have default tests, and we want to straight go to the results display, and mostly we will look for the average value rather than last update value. So the first test gives us 9.4K IOPS, and that's pretty good for a SATA. And the test is 100% read, 0% random, which makes it read sequential 4K. And we go to the next test, which gives us a bit less than that. It is 9.1, 9.2, 8 sometimes, something like that. And the second test is 100% write, 100% sequential. So sequential writes, as we all know from our experience, SATA is a bit slower on writes than on reads. After this, we are going to the very, very, very hard test, which gives us 400 IOPS, and it is a 100% read, and it is a 100% random read. We see 400 IOPS here, like 430 in average, and the last test is the hardest ever test, which is 100% write or 0% read. So it is a random 4K write, and it gives us almost 300 IOPS. And that's pretty okay for just a, SATA volume. We are stopping this test and want to go to the next drive, which is a common objective file system in StarWind with caching. So here it is. It's a G drive, which we can see here. I have NTFS on it, and yeah, so we'll do the test here. Also, the test file I have prepared for it as well, so that we are all ready to, go on the tap room. And it has caching as well, and mostly the performance will be provided by caching. And I just want to say that this is very synthetic test, and its results are like, in production, it is almost impossible to face such scenario, but still, I'm just showing the tests on small volumes. So over here, on the first test, we are seeing 30K of IOPS, which is much better than 10K. And actually, yeah, so 33 in average, 35 even, 37 now, 8, 40. Okay, which is 4 times better than what we saw, and it is growing, growing, and growing, and it eventually, from my experience, will grow up to 50K or so, which is much better than 10K we had. And this is the first test, which is the sequential read. The next test should show us almost the same performance. Yeah, it is like 57, 55K. And it is sequential write. After that, we have a random read. Yeah, the random read is pretty good as well. Gives us 65K VIPs. And then the last test will be random write, which is a bit slower, but still very good, and the hardest one possible. And the numbers we're seeing here and we were seeing on the local storage are very different. So on the local storage, on this last test, we had 285 IAPs, and right now we are seeing 57K, which is pretty awesome. Okay, so we finished the test for the common objective file system, and now we are going for the LSFS. We will unfortunately not see as good effort as we could, since this SAID alarm we have is not configured in a RAID 5, and this is not like real life production scenario, but still it will show us almost the same as good results as we saw on the common objective file system, but a bit better. So first time over here we saw 45, 40K on first test on the common objective file system, and right now we are seeing almost 60K. The next test will give us a bit less performance, but still a very good one. It will drop down to 52, maybe 50. And it is a sequential write. Then we go to a random read, which gives us a bit slower performance, but will grow back to a very good one. Yeah, we'll see it grow back to 50K or so, or even better. Yep, it does go back to 50K. And this is 100% random, 100% read. And then the hardest one is the random write, which is 55, 60K as well. And I think these results are very good. If we go back to what we were planning to talk about on this tap room, we did talk about almost all, I mean, not almost, but all of it. And then the most important part, and where I want to answer all your questions, is this one. So, shoot at me as many questions as you have, and I'll do my best to answer them. Scott had a very good question regarding LSFS. Do you recommend using LSFS on fast drives to get even better performance? No, unfortunately, LSFS is not designed that way. We recommend using it on a slow drives to get very good performance, where on fast drives, common objective file system will perfectly fit you. And if you want to get even better performance, it would make more sense to assign more level 1 caching than we recommend, which will provide you with a better performance on fast drives. Yeah, Scott, another questions. Flash cache should be write through. Yes, it should be in write through, and the default mode for it is write through. A good question from Isaac Low. Can you use both, have HA and asynchronous replication? Yes, of course you do, since this asynchronous replication was designed and usually used in disaster recovery scenarios. So you are running your production well and steady on using HA, and then in case of a disaster on your main side, you will always have asynchronous replication to back up from and use it somewhere else. For example, you have your synchronous replication on the other continent, and then on your main at your main site, when you are running your production, something happened to your servers, I mean physically or anything at all happened to them, and then you moved to another continent where you have your asynchronous replication and all your data is there, you simply take it and continue doing business. What is expected performance difference when using it in HA? HA makes it a little bit faster, but not as much. But makes it a little bit faster. Unfortunately, I didn't do that test, and this is a good idea to maybe do the testing, do such testing for the next tap room. How about LSFS to obtain deduplication on fast drives? That is a good point, but unfortunately our LSFS now has over provisioning, which will not be so good. But sometimes, in very rare cases, if you have very, very, very many VMs, like 100 or 200, and all of them have the exact same OS, it would make sense to go for the LSFS to get very good deduplication ratio, but this is this is an exception rather than the rule. There is a good question from Ahmed, which is basically about the difference in IAMs between the VMware and Hyper-V, because all the process in Hyper-V will happen from a physical host, where in VMware everything is happening from the virtual machine. And is there any difference in IAPS? It would actually make perfect sense to be different. So for example, Hyper-V faster, VMware slower, but to be honest, there is actually no difference at all. On both VMware and Hyper-V, the results are very similar. So the answer to the question is no, they both work very well. If your synchronous replication is broken, do you rebuild it from scratch? Yes, you can rebuild it, and usually if your sync channel is good and you have, when you were designing your system, you thought about synchronization channel, like you did think about it, and it is pretty fast. It usually doesn't take so long to rebuild a synchronous replica. It will take 30 minutes, and you will again be fully safe. So that's not an issue at all. Uh, Bruce, it's a very good question to get the realistic numbers, but unfortunately, right now on the small test lab, I'm not able to show you the real production scenario, and possibly in some close future, we'll have, I think, webinars rather than tap rooms, which will show you the testing and show all this in real production. In case, if you want to see it, you can get a trial, and if you have a real production scenario or a test lab where you can reproduce it, you'll be able to see the real results. How to improve the synchronization between two HA devices? You can improve it only by doing two things. First one is to improve the bandwidth or the throughput, whichever word you like better. So you improve the bandwidth of the synchronization channel, as well as improving the speed of your drives. That's it. Then your synchronization will be faster. Alessandro asked a great question. Can you use LSFS in HA? Of course you can. Why would then I talk about it? That's another good question from Ahmed regarding the storage present in the VMware. Is it recommended to present a physical storage to VM as a Vmdk file or in pass-through? Honestly, we did test that, and we had many questions regarding, this pass-through or Vmdk, and what we saw from the test results that it actually makes almost no difference between making a pass-through and Vmdk. So whichever way you like better, that way you can go. Can we expand the StarWind disk when they are live? That is a very good question. And yes, you can do that for the common objective file system. For the usual image files we have, you can expand them. But unfortunately, we cannot do that yet for the LSFS. I guess I answered all the questions. I'll wait for a few minutes if you have any further ones. And if you don't, we will finish the tap room. Yeah, go ahead, Ahmed. Alessandra, could you be please more specific about the AI feature? Well, basically, StarWind takes a storage that is available to it. It actually almost doesn't, not almost, but it doesn't matter how do you present the storage to StarWind as long as StarWind can access it. After StarWind can access it, you can or export the drive or create an image file inside it. After that image file is created, you have this device in StarWind as well as the target, and then anyone who can reach the host that has StarWind on it will be able to connect to that LUN and use it. That is basically it. Good question from Thomas. Is it better to have multiple small disks or show just one or show just one large disk? This is in terms of StarWind, there's no difference between those two. You can go for one or the other one, but in terms of best practices that VMware tell us about and that Hyper-V or Microsoft tell us about is that each VM should have its separate data store or cluster shared volume. So it is definitely better to have many small ones to be able to store VMs on them. Ahmed, I guess this is like not a taproom questions and not like very many people would be really interested in hearing that. And I would gladly answer to you, and to do so, I will have all the contacts. I mean, you will have all the contacts on your screen on the next slide. If you could contact someone from our sales and then get the trial. After that, you'll be connected to our engineer, and our engineer will gladly explain you all the architecture and even will be able to show you the demo and the way StarWind works in the real production, if that is something you are interested in. So, okay, we are going to the next slide where I want to thank you all very much. And I really appreciate that you're coming to these tap rooms. And yeah, thank you for coming. I wish you enjoyed it. And I hope to see you on my next tap rooms. And this slide, last slide has all the information you need to find us somewhere. And then if there is something you want to ask us about or get more information about, please use these contacts. And I wish you a great evening and a great future weekend. Bye bye.